If you interact with paleoclimatological data, particularly marine paleoclimatological data, data from sediment cores, you're likely to have encountered the marine isotopic timescale, which can be very opaque to look at the first time or so. This, as you might imagine, is based on marine isotopes. So what we're looking at right now is the Lazecki and Ramo benthic curve, or the curve of the oxygen isotopes in deep ocean foraminifera. This timescale is different from the Geologic Society of America's geologic column that goes back to the beginning of the Earth's history. In contrast, you can't talk about the Mesozoic based on the marine isotopic timescale because the marine isotopic timescale only covers the glacial, interglacial periods of the past couple million years. Instead, the marine isotopic timescale only refers to the past 2.5 million years, the period, the Holocene and Pleistocene, when the Earth has varied between warmer interglacial periods, like today, and cooler glacial periods, like 20,000 years ago, the last glacial maximum, when a lot of North America was covered in the Laurentide ice sheet. So one of the first things to know about this is if you're not familiar with the phrase KABP, it refers to thousands of years before present, which is one of the best ways to know when each stage is and to compare it against a timescale that might be more intuitive. So present will actually be defined as 1950 most of the time. That's the standard. There will be individual papers and cores that use either B2K before 2000, which is relatively straightforward, or that just put the top of their core as the present, and then comparison is much more difficult, even though it's much easier for the people writing that paper. So in general, the warm periods like today, like 130,000 years ago, the last interglacial, these are odd numbers, whereas periods like the last glacial maximum 20,000 years ago are even numbers. One exception is MIS3. So when they started analyzing marine sediment cores in the 1950s, they knew a little bit about glacial history. And they knew that there had been previous glacial periods and interglacial periods. And when they got to MIS3, which is like 30 to 60,000 years before present, they knew it was warmer than the last glacial maximum, and so they thought it was the last interglacial. However, it was not as warm as an interglacial period. Ice sheets were still very large. It was just somewhat warmer than the last glacial maximum. So MIS3 is sort of a mistake in developing a timescale, but it's stuck around partially because it's very useful because there are higher resolution records over the past 100,000 years, especially like if you're looking at ice cores, than if you're looking at very long timescales. So it is useful for us to have the specific term, the specific stage, talk about that period. But it does mess up the timescale, and it's just one little exception you have to remember. One thing to note when you're looking at this is that there was sort of a transition around 800,000 years ago to a million years ago. In the time that's been more recent than that, most of the glacial cycles, so one warm stage and one cool stage, have been approximately 100,000 years long. In the period earlier than the mid-Pleistocene transition, longer ago, each cycle was approximately 40,000 years ago. This is an interesting conundrum in science that there's a lot of active research about. Want to plot temperature in CO2, you can see this warm versus cool stage very clearly over the past 800,000 years. So when you see the T's, these are referring to terminations, glacial terminations. So like 20 to 10,000 years before present, was termination 1, the most recent end of a glacial period, a time when we've come into an interglacial, the one that we're living in which all of human civilization has happened in. Here you can see that CO2 and temperature have varied in tandem with each other over this 800,000 year time period that we have really good CO2 data from because we have CO2 data from ice cores. And you can see these stages. So you see 1, 5, 7, 9, and 11 as really strong, warm interglacials. And you can see periods like 6 and 8 as very cold and with lower CO2. I'm going to just mention a couple little things about a graph from a paper that I look at fairly frequently in order to hopefully convince you that this might be a useful timescale, at least if you're a paleoceanographer. One thing to note is that longer stages, such as stage 5, might be split into substages. So you can see here 5E, it's very warm. It's the peak of the last interglacial. 5D and B were a bit cooler. 5A was also relatively warm. You'll notice A, C, and E are like odd numbered letters. B and D are even, so it makes sense that they're the cooler ones. In this, you can see that delta 15N is lower in the modern period and in 5E. There's also a little peak in 5A. It's useful to think of this just as 5A rather than, 85,000 years ago, and trying to remember exactly what the climate was like then. If you've got 5A up here, even if you didn't have this plot of the Antarctic temperature stack, you could remember that it was a warmer period. So anyway, it might not be relevant to everyone's research, but it is to mine. And if you watch this video, maybe it is to yours. So hope this helps.